like to start by saying welcome to all of you who are joining us from around the world at this, our inaugural Datasphere virtual conference. I hope you and your families and friends are staying safe, and I thank you for taking time out of your busy schedules today. I'd also like to thank our partners and customers for your participation in what I think will be a truly valuable experience. As we wrestle with and hopefully shed some light on the challenges we're facing as businesses, managing enterprise data and putting it to work. What I'm planning to talk to you about today will give you a sense of Seagate's perspective on this topic, how we believe businesses like yours can succeed, and also introduce some of the new exciting solutions we're announcing exclusively today to help you tackle these complex challenges. Let's dive in. We live in a data economy, and as both consumers and businesses, we're all active participants. In this data economy, data itself is the currency. We exchange it, we transact with it almost every day. It's dynamic, and in the enterprise, it flows in and out of our organizations between departments and cross-functional teams who are tasked with creating value from it. Organizations are in a race to increasingly leverage data for competitive advantage. The successful ones have realized that to do this, they're required to treat data differently and apply many different skill sets and practices to its management and ultimately its monetization. With that said, the data economy is about to undergo explosive growth, with data projected to triple in size by 2025, according to our partners at IDC. This presents a tremendous opportunity for the enterprise. Over the past decade, we've witnessed the third major IT revolution since the invention of the computer. The emergence of cloud computing, where data created and captured on billions of endpoint devices migrated up to a centralized IT infrastructure. This era has really been dominated by the hyperscale public cloud companies who were able to capitalize on and in many ways helped to create the data economy. One of the primary drivers for how these companies were able to do this is with data. They figured out the direct correlation between the accuracy of AI and machine learning training models and the size of the data sets with which they're trained. More data simply begets better analytics, which begets better business insights and better products. But it's not just a matter of amassing the data. The public clouds have mastered its end-to-end management, its end-to-end value extraction, and the monetization. They're the pioneers of the hyperscale data center. They've built the blueprint for optimized storage environments, and there's a lot we can learn from them. Hyperscale storage architectures are optimized for massive capacity. They're fine-tuned for maximum resource utilization and engineered for ultra-efficient data management. Their proprietary software stacks are customized to leverage the latest innovations in HDD technology, and we partner closely with them to help them drive their roadmaps. Meanwhile, we're embarking on IT 4.0, the rise of the edge, the fourth major IT revolution, which is being driven by the proliferation of IoT devices and 5G connectivity. Enterprises have new data sources that are highly complex. They're unstructured data, and they're really, really hard types to manage. Monolithic centralized storage architectures are being disrupted by the need for latency-sensitive applications placed at the edge. These new hybrid architectures incorporate multiple public, private, and geo-distributed edge clouds, and they're emerging in order to capture this data opportunity as storage shifts back to a decentralized model. Underscoring this shift in IT architecture, here's an interesting finding from the recent Rethink Data research by IDC. As data inevitably grows, it will continue to be evenly distributed across multiple data center, edge, and cloud storage environments. Data growth and data sprawl are two key attributes of IT 4.0. Which create enormously complex data management challenges for businesses as they adapt to the new architectural imperatives of the distributed enterprise. So if we go back to the data growth forecast from IDC that shows the total amount of data that humanity will create by 2025, and then we segment it by how much of the data will actually be stored versus how much will not be, we can begin to quantify the problem. There's a clear and increasing disparity here, which culminates in less than 10% of the totality being stored in 2025. And this is a paradox. If we truly live in a data economy, where data is the currency and the key to competitive advantage as well, why is so little of it being actually stored? We believe that there are two primary reasons for this paradox. First, the cost of enterprise storage is prohibitively expensive to enable enterprises to capture the opportunity. More efficient, scalable, affordable solutions are required by IT orgs who are being asked to do more and store more with less. And second, most of the 175 zettabytes previously mentioned will be machine generated. It'll be unstructured, and it's geographically diffused. Management of data across various locations, multiple clouds and platforms is prohibitively complex, especially for IT orgs, which are generally already resource constrained. Data becomes siloed, stranded, and unusable. To overcome the complexity, enterprises need open architectures. They need new management approaches to the data. And they need simple and easy to deploy solutions so they can mobilize, consolidate, and analyze data at the required volume and speed. At this scale, with the relentless growth of data and the 24/7 cost implications of storing it, today's multi-cloud solutions and configurations where each vendor has its own unique tools, policies, cost models, and inherent motivation to retain customer data within their own ecosystems, that's not the whole answer to the storage cost and complexity challenges. Organizations are forced to compromise in the data economics equations. And the cost of storing more and more data, can seem like it outweighs the value that can be derived from it. To address all of these issues, we believe there needs to be a shift in both paradigm and operational approach. We already talked about the idea of treating data as a currency. We believe that in a literal sense, data is a corporate asset that will one day be reflected on the balance sheet. So instead of a world where we can only store what we can, we want to create a world where we can store as much data as we want. In this world, closed-off proprietary architectures are replaced with open, composable, hybrid architectures where data moves freely and efficiently across the distributed enterprise. It's no longer trapped in silos. Management of data and storage tiering decision-making is automated, and it's optimized for efficiency based on policy and predictive modeling. Data stewardship is no longer constrained exclusively within the boundaries of the IT function, but instead democratized across interdepartmental teams. And data growth is enabled by data ops model that allow full access to disparate data sets across the enterprise. And there needs to be an environment for AI-driven innovation. All of this will pave the way for predictive insights that drive digital transformation and competitive advantage. There's an industry movement to software-defined storage and hybrid architecture that's already underway for improved interoperability between parts, controls, and better economics, amongst other factors. However, when it comes to actually standing up private cloud infrastructure, the current storage stacks available to the enterprise today remain complex to deploy. They're complex to maintain and to manage, and given that TCO is still the prevailing gating factor to storing more and more data. Seagate is uniquely positioned to help solve these operational and architectural data management challenges. For 40 years, we've been focused on solving the constraints of enabling the efficient storage of mass capacity data across two primary device level vectors, HDD capacity and HDD performance. This month, we announced the availability of 18 terabyte drives. And even more significantly, HAMR, or heat-assisted magnetic recording, will ship in production later this year, enabling capacity points initially at 20 terabytes, but ramping to 50 terabytes by 2026. Mach 2, our multi-actuator technology, will enable HAMR drives to maintain performance SLAs as capacity scales. Let's take a look at why we believe these two innovations are so vitally important to enabling the future we've been discussing. The simple fact is that data center storage infrastructure cannot be competitive without mass capacity HDDs, especially at the size and scale that we've been discussing today. As this chart shows, with each capacity point increase, there's a significant improved cost per terabyte. And because of this dramatic TCO advantages, HDD technology will have a critical role to play across the distributed enterprise in the public cloud, in private clouds, and in edge cloud environments. We anticipate this being the case for the foreseeable future as we continue our mission to store as many bits as physically possible on these devices. The hyperscale public clouds understand these device-level economics implicitly. They've realized that advancements in HDD technology give them an enormous cost advantage, and to sustain it, they continuously adopt the highest capacity drives as quickly as they become available. But when it comes to the enterprise data center, the path to adoption is less straightforward. The hyperscalers have built proprietary software stacks, co-developed with open, industry-standard hardware to minimize bill of materials, to help them realize the full benefit of HDD innovation, and to achieve maximum efficiency, scale, and system resilience. Enterprise data centers currently don't have an easy, clearly defined path to get there and remain competitive. Despite the cost efficiencies these device innovations will enable, they are in themselves insufficient to solve the problem. They only get us partly there. To fully realize the TCO benefit of HAMR and Mach 2, the data center requires a completely new storage architecture designed with and for these devices. Introducing Project Cortex, intelligent object storage software designed specifically for the enterprise to exploit the full capability of these HDD innovations and shortcutting the path to adoption for them to get into the data centers. Cortex is fully optimized for data resilience, for cost, and for architectural efficiencies required for mass capacity workloads. It's infinitely scalable and designed for distributed multi-site deployments to capture the unstructured data explosion. Cortex will be 100% open source, meaning that as well as enabling a community-driven feature roadmap with faster time to innovation and freedom from vendor lock-in, we're eliminating the cost of object storage software licensing from the whole data center stacks. In addition to making storage more scalable, more efficient, more resilient, our objective with Cortex is to enable enterprise data centers to increase the amount of capacity they can afford to buy. We're converging all of this innovation into an object storage solution called Live Drive Rack, built for mass capacity workloads. It's S3 compatible, validated with multiple ecosystem partners, and delivered as a rapid deployment ready reference architecture. It's powered by Cortex, so it has all the benefits of our 100% open source community-driven design, but it's fully indemnified and supported by Seagate. And when loaded with 20 terabyte HAMR drives, it will deliver unprecedented density with up to 2.1 petabytes in a single unit and up to 8.4 petabytes in a single rack. Seagate is truly bringing the hyperscale storage blueprint to the enterprise. To enable that blueprint, we have a full stack, tightly integrated product strategy, harmonizing devices, systems, silicon, and software all together. We just launched the highest capacity hard drive in 18 terabytes earlier this month, and 20 terabyte HAMR is imminent, with drives shipping later in this calendar year. With Cortex, customers can easily adopt these high capacity drives into their own private storage environments and exploit their full cost advantage in the same way the hyperscale clouds do. All of this is easily deployable with a high density converged reference architecture and Live Drive Rack. Customers can seamlessly and affordably stand up and manage private cloud infrastructure to consolidate and access massive unstructured data sets at the frequency and volume they want to without friction, without security risk. We are truly democratizing hyperscale storage architectures, and we're just getting started. Our entire product roadmap is based around the vision of building a frictionless future for the world's data through open edge-to-cloud data management solutions. Partnering with our customers to reduce their cost and complexity of their infrastructure, we enable them to store more data, to create more value from it, and ultimately win in the data economy. And now to tell you exactly how we're going to build that future and show you a live demo of the innovations we've talked about, please join me in welcoming Ken Claffey, VP and General Manager, Enterprise Data Solutions.
Welcome. My name is Ken Claffey. I run the Enterprise Data Solutions business here at Seagate. Seagate has always been a significant contributor to data storage standard bodies and various open source software projects. And today, I'm excited to introduce to you our latest contribution in the form of Project Cortex, a mass capacity optimized object storage software stack designed to meet the needs of private cloud storage in a hybrid cloud world. It's 100% open source, and we already have a vibrant community of active contributors. Before we dive into Project Cortex, let's just take a second to revisit the big story that underpins everything we do at Seagate. Earlier, Dave talked about an emerging problem, the inability of organizations to store massive amounts of data. This data has tremendous and immediate latent value to your organization. The vast majority of that data is unstructured. We're talking video, audio, imagery, and sensor data. Storing unstructured data at the petabyte or even exabyte scale presents some unique storage challenges. At Seagate, our mission is to help enterprises deal with this explosive data growth that is a result of the proliferation of IoT, machine-to-machine learning, artificial intelligence, and big data. We want to start by sharing our learning as the leading provider of bytes to the world. How can enterprises efficiently, securely, and simply store more data? We're seeing enterprises increasingly move to adopt greater and greater automation in the data center, with increasing uses of containers, Docker, and Kubernetes, all technologies pioneered by the hyperscalers. We believe the same adoption cycle for hyperscalers to mainstream enterprises will be true for private cloud storage, an essential part of any hybrid cloud architecture. Hyperscalers have been completely reimagining and redesigning the enterprise stack, eliminating layers and complexity to maximize capacity, performance, availability, and durability, all at the lowest cost. We believe that all enterprises can learn from this blueprint and benefit from this approach. To break this down, there are 3 principles as it relates to data storage that hyperscalers have all uniformly applied. The first is software-defined storage, based on their own distributed object storage software. Secondly, using industry-standard servers and storage hardware. And lastly, this entire blueprint is based on a disk-centric architecture which enables them to benefit from the lowest total cost of ownership with the rapid adoption of the latest HD technology innovations. Software-defined object storage plays a huge role in the hyperscaler blueprint and even their business models. They use object storage because it's best suited to manage mass capacity. It's designed to handle petabytes and exabytes of unstructured data. It offers the best combination of scalability, performance, manageability with simplicity, and economics. Object storage is at the center of hyperscale architectural blueprint as it enables them to harness the economic advantage of mass capacity storage devices. But their stacks are proprietary. Enterprises also need access to the same type of mass capacity object storage software, enabling them the timely access to the optimal storage media. And preferably one that does not come with exorbitant license support fees or require massive resources to manage. Well, as Dave mentioned earlier, hyperscale storage clouds are based on a HDD-centric architecture, whereby 90% of the data is stored in disk drives with less than 10% in a small but effective flash caching tier. They do this because HDDs are a near order of magnitude cheaper storage. It's that simple. Therefore, they pay extremely close attention to what's happening at the media level, especially when it comes to adopting the next generation of HDD innovation. The hyperscalers aggressively consume every areal density advancement the hard drive industry can deliver in order to get them the lowest cost per bit while still maintaining all their SLA requirements. They are currently almost 2 full hard drive generations ahead of the mainstream enterprise providers, and that difference is set to grow as we transition to HAMR, a new type of media which brings with it accelerated improvements in cost per bit. Simply put, the cost penalty of being behind the curve in adopting the latest HDD technology is going to get bigger and bigger. At Seagate, we want to help enterprises stay on the lowest cost curve and not fall behind. To do this, we're making investments to enable the adoption of the latest media innovations and bring this hyperscale mass capacity optimized blueprint to the enterprise. This is why we are today announcing Project Cortex, Seagate's intelligent, mass capacity optimized open source object storage software that will bring the hyperscale advantage of software-defined storage along with the rapid adoption of new media to the enterprise. Cortex is built for efficiency, performance at the petabyte and even exabyte scale. It was designed from the ground up to be optimized for mass capacity to enable the next generation of storage media, HAMR and the 50 terabyte drives it will deliver. Cortex development has been an open and cooperative effort spanning many years, involving a broad set of contributors across users, integrators, OEMs, and developer community. The focus of this collaboration has been to find new ways to efficiently deliver mass capacity storage to the enterprise. To date, over 1 million lines of Cortex code have been built and tested. And when we say open source, it's not the core is open source, but you need all these other pieces of proprietary code to install it, to manage it, to scale it, to make it actually work. No, the entire code base, the entire stack is open source, even the GUI. Project Cortex has been built from the ground up to address so many of the emerging data management and cost challenges facing IT organizations. The result has been a number of industry-first innovations, to the point where we like to say Cortex is an intelligent object store. Here are just a few examples. Cortex can write directly to disk. This is a unique feature that bypasses cumbersome file system layers. There are millions of lines of code of firmware in every drive. Cortex is uniquely able to access and unlock all the capabilities of the drive, maximize capacity, performance, and deep telemetry. To ensure data resilience for ever larger data sets, Cortex's novel approach to erasure coding can provide a multi-tiered data protection across the stack, providing against data loss and ensuring availability against a myriad of data center failure scenarios. With intelligent metadata management, Cortex has its own integrated, scale-out, auto-indexed key value store to simultaneously enable scalable labeling and the search across exabytes of data. There's no point in saving all that data if you can't easily search all that data. Project Cortex has been designed for this level of extremely optimized metadata search at scale. Cortex also has monitoring automation capabilities that continually analyzes the entire stack, including the hardware, and identifies performance bottlenecks and other operational issues proactively. Part of Cortex's uniqueness is that it is the only object storage software optimized for mass capacity drive technology. It has a greater awareness of the underlying storage devices and the media that actually store the data. This allows us to introduce new capabilities at the device level that can be immediately leveraged by the enterprise, ensuring that users of open source Project Cortex have access to all the optimal storage media. Another key benefit of Project Cortex is to show hyperscalers, OEMs, ISVs, how best to use these new storage devices such that we enable an ever broader adoption of Seagate's innovative mass capacity storage technologies. To make it easier for developers and enterprises to quickly deploy a hyperscale-inspired private cloud storage solution, we've teamed up with our partners to create the first in a series of open multi-vendor converged infrastructure reference architectures that we call Live Drive Rack. It's a fully validated, supported, pre-configured solution built with a growing list of world-class partners that includes everything you need to get up and running with Project Cortex. The storage hardware, application servers, networking, the full software stack. As you would expect, Live Drive Rack is also on the cutting edge when it comes to the integration of the latest hard drive cost and performance innovations, enabling private storage cloud builders to deploy architectures that rival the performance, efficiency, manageability, and cost of the world's most innovative hyperscale storage clouds. Live Drive Rack will be available through our partners starting in December. Lastly, but most importantly, Project Cortex is all about being inclusive and open. It means that it is free from vendor lock-in and open for a global developer community to contribute. Seagate has a long-standing history of more than 20 years of innovation and contribution to object storage. We quite literally helped author the original object storage SNIA specification, and we are an active contributor to numerous open source projects. So it's very natural for us to partner with a growing list of more than 50 diverse developers, OEMs, and users as part of Project Cortex. I want to thank our early collaborators, and we're looking forward to welcoming even more members to our community. With more than 1 million lines of code and growing, we want to invite developers to join this vibrant Project Cortex community now hosted at GitHub. And now, I want to show you a quick demo of Project Cortex in action with Live Drive Rack and how easy it is to deploy the next generation 20 terabyte HAMR drives.
In many ways, hyperscale cloud architectures provide the blueprint for how data can both be efficiently preserved and utilized. At Seagate, we've been busy building the next generation of mass capacity storage devices, while simultaneously working with the open source Cortex community to develop the next gen mass capacity optimized object storage software stack. We've also been working with our partners to establish a hardware ecosystem to make the do-it-yourself deployment of this mass capacity platform easy. This collaboration has given us the Live Drive Rack Converged Infrastructure Reference Architecture, a hyperscale-inspired cloud storage blueprint that's easy to buy from off-the-shelf parts and building blocks, deploy and manage. Let's start with Seagate's HAMR drives. HAMR stands for Heat-Assisted Magnetic Recording. It is the next generation of mass capacity storage technology that dramatically increases the areal density. This is a factory-fresh 20 terabyte helium-filled HAMR drive. HAMR brings real TCO benefits to the data center by reducing the cost of storing a bit. This means that storing data becomes even less expensive. These are currently being built for strategic customer evaluations, but we'll be shipping them in our systems later this year. Next, let's examine how quickly HAMR comes online, and then we'll showcase the power and simplicity of Cortex object storage. All Seagate hard drives, including HAMR, are designed to work together seamlessly with Cortex and the Live Drive Rack reference architecture. We can immediately insert the drive in our system without tools or the possibility of misalignment. Once in place, the system automatically recognizes the entire capacity of the new drive, regardless of the capacity of the other drives already in the system. This unique capability to handle variable capacity drives enables Live Drive Rack to always realize the maximum capacity of the drive. It's not just limited to today's 20 terabyte capacities, but also the 50 terabyte HAMR drives we will be delivering in the future. In conventional systems, adding even a 20 terabyte drive typically looks very different. In many cases, the various parts of these systems and their overall software stacks are just not able to handle the scale of these next-gen mass capacity devices. Now, let's look at the single pane of glass management console. We can see it quickly recognize the capacity of the HAMR drive and seamlessly add it to the available pool of Cortex storage. The management console provides simple and easy volume creation and management of your data. Using Cortex object storage software, you can now manage large sets of unstructured data with faster setup, simplified management, and this is all based on an open software and hardware platform. Seagate, together with our partners, is enabling a full solution stack that brings modern, hyperscale cloud storage architectures to the enterprise, helping them to keep and monetize more of their data than ever before and realize the vision of a super efficient, hyperscale-inspired private storage cloud infrastructure to manage the flood of unstructured data.
Thank you for your time today. We're excited to be on this incredible journey together. We also have much more Project Cortex information for you during our Datasphere conference. So please be sure to check out our presentations from John Bent, our Community Director and Principal Architect, together with Gregory Turetsky, our Live Drive Rack Product Manager.